right, so just another example of using given terms of a sequence, a geometric sequence, in order to find a future term. Again, I like to point out when you do look at these a little more carefully, they do not give you the first term or the common ratio. So again, if I'm ever asked to find a future term, I'll always go and figure out what my formula is for the nth term. So for geometric sequences, we have a sub 1 times common ratio to the n minus 1 power. And if I'm asked to find n equals 14, that's a sub 14. All I'm doing is just plugging in 14 wherever I see n. And so that's going to leave me with a sub 14 equals a sub 1 times r, and then simplifying it, 14 minus 1 is 13. So now I have something to look off of. My goal would be to figure out who is a sub 1 and who is r, so that I could actually find the value of that 14th term. So if you've done a few of the previous examples, or you've practiced a little bit, the way we work with these, the same idea, we're just going to take the idea and look at the fact that if we're given the fourth term, that's telling us that n equals 4. We can plug this in to our general formula, which is right here. So if I do that for ourselves, we get a sub 4 equals a sub 1 times r to the 4 minus 1. You can simplify it. A sub 4 equals a sub 1 times r to the third power. We can do the same thing. If n equals, this will be 10 for the second term, or it'd be a sub 10. We have a sub 10 equals a sub 1 times r to the 10 minus 1. Just clean it up a little bit. A sub 1 times r to the 9th. That's the value of a sub 10. And now, since we do have the values of both of these terms, a sub 4 is 125 equals a sub 1 r cubed. And a sub 10, we do have a fraction. 125 over 64 equals a sub 1 times r to the 9th. So again, we have a system of two equations. They're dealing with products and factors, so we want to be careful for ourselves. We're probably going to use substitution. And generally, whenever I use substitution, I use the nicest equation to work with. So I'm going to probably look at this first equation, and I'll solve it for a sub 1, or I'll solve it for r. But honestly, if I'm looking at it, it looks like a sub 1 would be a good candidate to solve for. Looks like that's going to be a little faster because a sub 1 only has a power of 1. If I solve for r, I'd have to be dealing with cube roots or something. So if I solve for a sub 1, what I end up getting, I would divide both sides by r cubed. So that would leave me with a sub 1 equals 125 over r cubed. So that's nice. All we do is we plug this into the next equation. So I still have 125 over 64 equals, now a sub 1, I'm going to plug this in, that is 125 over r cubed times r to the 9th. Now you can use laws of exponents to deal with simplifying the r's. Remember, this r is over 1. So in a way, we're looking at dividing with the same exponent. We're keeping the base and we're subtracting the exponents. So we still have 125. Nothing has happened there. And what we're dealing with would be r to the 9 minus 3. Or if you reduce it, it's r to the 6th. Okay, so on the left-hand side, we still have 125 over 64. Now we'll probably be solving for r. So at this stage, what you want to do is you want to isolate the r. So if we were to do that, technically you're dividing both sides by 125. And if you divide this other side by 125, it's like multiplying by 1 over 125. So that's kind of nice because the 125s divide out. But be extremely careful because what we have here is 1 over 64. Remember, when things divide out, you're left over with a 1. So we have 1 over 64 equals r to the 6th. So we're almost there. Next stage, if you want to find what r is, we have to take the 6th root of both sides. Now, a little bit of work. I know 64 might not be too crazy, but I do know as radicals work with fractions, it's really like looking at what's the 6th root of 1 over the 6th root of 64. And it's kind of nice because the 6th root of 1 is 1. So we do have r. I'm going to move it over just a little bit if you don't mind. So r is 1 over. Now 6th root of 64, I'm guessing it's probably going to be a 2 because I do know that, well, I kind of know my powers. So 2 to the 5th equals 32. So I think it's 2 to the 6th is 64. But we can check if you'd like. You want to go to the TI really quick? Sometimes you don't believe me. I get it. Now you want to find the 6th root of 64. We would press the 6 first, the math key, the X root key, and then we have 64. And voila, we do get a 2. So I always like to check myself just in case. Maybe especially when I take exams, sometimes my mental math is not as sharp as it would be when I'm not as nervous. So I feel pretty good. R, the common ratio, is 1/2. Now we can go and take that and plug this in to our formula above here and see what we have. A sub 14 equals a sub 1. We don't know what that is quite yet, but we do know that R is 1/2, and it should be taken to the 13th power. And I'm going to avoid taking things to the 13th power at this moment because I really want to figure out who a sub 1 is. So let's go back and clean up the system. We already figured out that a sub 1, R is 1/2. So if we look at our a sub 1, I'll take this off to the side. If a sub 1 is 125 over r cubed, then r is 1/2. We can just take a little bit of time and simplify this math. I'll go sideways. 125. Now 1/2 cubed is 1/8. 1 times 1 times 1, 2 times 2 times 2. And you have yourself a complex fraction. So with a complex fraction, that's like saying 125 divided by 1/8, which leaves us with 125 times 8 over 1. And if you'd like, what you can do, you can find the answer, 125 times 8, which actually, look at that, very nice number, 1,000. So that is a sub 1. We're going to take that up and replace that into our formula. A sub 1 is 1,000. And in this stage, what we can do is, I wouldn't take 2 to the 13th, in my head. I might just plug this into my calculator. So let's go back to our TIs. Take some time. And remember what we were finding. It was 1,000 getting multiplied by 1/2 raised to the 13th power. So remember, it's 1/2 taken to the 13th power. Now I know I have a fraction. I'll press enter first to see what I get. And yeah, it didn't end up being a nice integer. So a lot of times what I will choose to do for myself, I'm always going to check to see if the calculator will give me a nice fraction form for this. And I know we can do this by hand, but why if we have our calculator? And voila, you see it. It is a very nice fraction. Well, maybe not nice in your eyes, but it actually ended up being able to be turned into a fraction. So we finally have, I'll switch over to write our final answer in. We do finally have what a sub 14 is equal to. A sub 14, exact value would be given 125 over 1024. And so hopefully by seeing this example, you don't get too intimidated when you see fractions. We can work with them. We definitely have the experience with this, and our TI does help us out along the way. So best way to get better at these is to keep practicing, do a few more homework problems, and I will see you in the next example.